So today we're going to talk about one of our notes. We're going to hand draw this just simply because I've never seen a worksheet that covers what this is going to accomplish for us. We're talking about interior and exterior angles of polygons. So first of all, the first thing I notice, this is a triangle. I've drawn these four shapes, okay? How many sides?
2.
How many sides does this shape have, a triangle?
3.
3 sides. How about the rectangle there?
4.
4. How about the pentagon?
5.
Okay, how about the next one?
What is that?
6. Okay, so we're just looking here, number of sides that I have. Nothing big, nothing complicated.
What's the last one called? Just like
Hexagon.
polygon?
Heptagon. No, hexagon. Heptagon is 7. All right. So when we look here, okay, I look at then if I were to start here, how many triangles do I have here in this picture? 1. Okay. If I were to draw from the vertex, we're just looking to see if I were to draw a line from one vertex across. Okay. If I draw a line here, I've still got a flat line. Here, I've still got a flat line. So here I have 2. Here I have 2 triangles. Okay. If I draw a line from here to here, I've still got a line.
Couldn't you be able to get more than 2 triangles on the square?
Right. Well, you could, but we're talking about from one vertex, drawing lines straight out to opposite vertexes. Basically, one line connecting to the vertex. I've got 2 triangles. From the Pentagon here, big building in Washington, D.C. also, by the way. Okay? If I go across, I can go to this one, and I've got 3 triangles. Right?
Yeah.
Okay? In other words, I draw a line to every vertex that's not already a straight line. Okay? And if I draw a line from here, let's say from this vertex right here, I go down here, across, and across. This one's already connected by a line. That one's already connected. I have the number of triangles that I can create, because these are straight sides. We're just looking at the number of triangles I can create here is 4 triangles. Okay? So what I'm trying to do here is I'm trying to help you make a connection between, we're going to make a connection between the number of triangles in here and the number of degrees that interiorly and exteriorly that a shape will have, right? Okay, so here with my triangle, okay, what are the interior angles of a triangle? Okay? They are 180 degrees, right?
Right.
So if I were to put the total degrees that I have how many? 180 degrees total. Okay? Okay? If I were to say, all right, so times the number of triangles, there's 180 degrees per triangle that I have. Okay? You guys beginning to see that triangles become like sort of like the building blocks
Just
for
multiply it
everything we do?
triangle.
Right. What's 2 times 180?
360.
360 degrees. And that makes sense because if I have a rectangle, then I have 4 right angles. And we already know that 4 right angles make 360 degrees. Okay? Well, if I've got 3 triangles, then I've got 540. If I've got 4 triangles, I've got 720. Okay? So this tells us then that what we're looking at here is that if I take any shape, so if I were to increase this to a 7-sided shape, and then I were to still have the number of triangles increase, basically the more sides my shape has, the more triangles I can draw in it, and the more interior angles that it has. Okay? So then in any regular polygon, we get this equation. Okay? So if you notice, what was the relationship between the number of sides and the number of triangles?
1
One
per
triangle,
3.
sides.
Okay, so how much did I decrease here? I did the number, okay, to get to this number right here, I took the number of sides, and I subtracted what?
2.
I subtracted 2, and to get the total degrees, what did I?
You took the number of triangles and multiplied it by 180.
So I took basically the number of sides minus 2, number of sides minus 2, and then I multiplied it by 180 degrees. Okay? And this gives me the number of this gives me the total degrees of interior angles. Okay? Which then, if I want to figure out, so for example, if I want to figure out how many interior angles, so let's try this one. If I gave you a 13-sided shape, okay, 13-sided shape, I would have 13 minus 2 is 11, and I would multiply 11 by 180, and that's how many degrees that I would have. Okay? So, that is an equation
1060 degree.
to get the total number of sides. Okay?
What is the S stand for? S equals
Sides.
Sides.
I thought n equaled number of sides.
N is the number of sides. S is just standing here for the total number of
Degrees.
the total degrees that are inside the interior angles add up to. Now, if I also have, let's take it a step further, if I have 3 sides, how many angles do I have?
3.
Okay? So I can say that I have the same number of sides as the same number of angles. Okay? So as a result, if I want to, at the same time, get the specific number of degree of each interior angle, so if I wanted to say, for example, if I wanted to say, I know that this is how many that this will give me, okay? This will give me, so if I put 4 in here, I have 360 degrees, but how much is each interior angle? Okay? To get each interior one, then I would just divide all of that by the number of angles or sides that I have. Okay? Does that make sense?
You would.
Then
Oh.
that is to get the degrees.
Okay. In other words, so if I put this into here, so let's say, for example, I were to put that into there. Okay? And let's say that I'm going to, see if we can get in view here, there we go. If I take this equation, right? And let's say, for example, I want to find each individual angle on a square. Now, I already know that a square has 4 sides and 4 angles, and that each one is a right angle, right? Right, we already know that. But let's see if we can prove it. So if I take 4 minus 2 times 180 divided by 2, then I get 2 times, or divided by 4, then I get 2 times 360, or 2 times 180, sorry, 180 divided by 4, which gives me 360 divided by 4, which then gives me 90. Does that make sense?
Wait, what is this?
So this just told me for the number, this is the size of each interior angle. This one is the sum of interior angles. Okay? So then another principle we're going to learn is that the sum of the exterior angles. So for example, let's say for example I had an equiangular triangle. What would be the interior angles of a triangle that's equilateral, that they're all the same?
60.
60 degrees. We learned that in the last unit. Okay? Let's say I were to continue these out so I had external angles. Okay? Based on the principle of linear pairs, to find the external angles here, we take 60 plus some angle equals 180, right? Which means that the exterior angle of a triangle that's equilateral is 120. Now I have 3 of those angles that are all 120, right? The exterior angles, this is a principle we're going to learn, that the exterior angles of any polygon, of a regular polygon, are going to always be, because I have 3 of them there, they're always going to be 360. Let me prove it to you another way. If I were to extend the square out here, or the rectangle, like so, okay, each of these exterior angles would be 90 degrees. I have 4 of them. 4 times 90 degrees is 360. So, the total exterior angles is 360. Does that make sense?
So you used a whole different thing.
So we're talking about interior angles of a polygon and exterior angles of a polygon, right? So this is always, 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 they will always be of a regular polygon. They will always be 360 degrees.
No matter what the shape is.
No matter what the shape is, if it's a regular polygon. Now, if I wanted to find, that's just a principle, if I wanted to find the size of each one, if I wanted to find the size, I would simply take this and divide it by the number of angles that I have. So in this case, no matter what I have, I'm going to have, the number of exterior angles that I'm going to have is always going to be the same as the number of interior, because they're linear pairs. Okay, so notice here that the 60 and the 120 are equaling 180. The 60 and the 120 are equaling 180. The 60 and 120, the 90 and the 90 are equaling 180. If I were to take my pentagon and I were to extend out this, just extend out straight lines to have exterior angles, okay, the sum of the degrees here is 50 degrees, or 540. 540, we're trying to find the measure of each interior angle. Divide that by 5, and the degree of each interior angle would be 108. So if these are all 108, the exterior angle is going to be 180 minus 108. That's going to be 72. And if I take 72 times 5, I get 360 again. Okay?
Okay,
So this gives us, this is the total exterior angles. Okay? And this one is the size of each exterior angle. Okay? This little cheat sheet, a part of 3.5, topic 3.5 that we're learning about, I think will probably come in really big handy because this gives us a little chart that we can overview. So to recap, I take the number of sides or angles that I have. Depending on that, I can form triangles just from one vertex. How many triangles can I form? Okay. Multiply those triangles by 180 because that's what the interior angles of a triangle equal. This gives me the number of degrees. Okay. Then I figured out that since I had 3 minus 1, which gave me 2, so the number of sides minus 2 will get me actually the number of triangles that I had. So if I have a shape that's 8 sides, class, how many triangles will I have?
4.
How many?
Six.
I will have 6 triangles, which then I'll just multiply by 180 degrees. Okay? And if I want to figure out how much the interior angle is, each one will be divided by just the number of angles that I have. Does that make sense? So if I want to figure out, for example, if they tell me in my carton of cookies that my total calories are 500 calories in this carton of cookies, and I want to figure out how much each cookie is, I divide that by the number of cookies that I have. And typically there'll probably be more than 500 calories in a carton of cookies. I've learned that, me and my waistline have learned that the hard way. Okay? The exterior angles of any regular polygon are always going to be 360 degrees. That's never going to change. Okay? And to find the size of each exterior angle, I just divide it by the number of sides that I have.